All right, in this application of compound interest video, we're going to work with two fun little things here. So I recommend you hit pause and read through this. I'm not going to read it all to you. So hit pause, read it, come back, and then we're going to do some math. Okay, so hopefully you read it. So the important pieces is that we have 2.25% annual compound interest. We started with 93 cents. And we worked on 1,000 years. So Fry thinks that he now has $4.3 billion. Could 93 cents lead to $4.3 billion even over 1,000 years? That's hard to believe, but let's check it out mathematically. So if we start with 93 cents, 1 plus my interest rate, 0.0225. It's compounded annually, so that's just once, so I don't have to divide by 1. And we're raising that to the 1,000 years. If you plug that into your calculator nice and slow and make sure that your numbers are right, you get $4,583,508,450. So $4.3 billion, yeah. That rounds to 4.3 billion. So it's crazy to think that 93 cents could turn into something so large. And the only problem is for us, none of us are going to live 1,000 years. So you can't throw in 93 cents at 2.25% interest rate annually and be excited about $4.3 billion because you're not going to be here for for 1,000 years. So it's great in the episode of Futurama, but it's not applicable to real life. Okay, let's talk about Ben Franklin. So you might want to hit pause and read it, but here's the gist. Ben Franklin supposedly left Boston and Philadelphia money that would help the cities grow. So he left about $5,000 to each city, and at an interest rate of 5% compounded yearly, and they weren't allowed to touch it for 100 years. Okay, so first, let's just answer question 2 based off that information. If they started with $5,000 at a 5% interest rate compounded annually for 100 years, how much money would they have? And the answer is $506.29. That's a pretty penny. Well, then they were said, okay, after that 100 years, you can spend 3/4 of it, and the rest has to be invested for another 100 years. Okay, well, 3/4 is 0.75. That's how much they can spend, which means they have to invest 0.25, right? 25%. So, number 3, assuming they had the amount estimated that we just did, how much should they have invested? Well, they needed to invest 25% of that amount, of the $657,506.29. So 25% of that comes up to be roughly $164,376.57. Now that means that they could have spent approximately $500,000. And this was back in 1790. So 100 years later would have been 1890. I wasn't alive then, and neither were you. But I'm guessing that $500,000 back then was a lot of money. I mean, $500,000 today is a decent amount of money. I mean, maybe not to build a skyscraper or something, but if you're just building a house, $500,000 is a huge house, right? So if they reinvested this much money for another 100 years, so $164,376.57 at 5% for 100 years. So this would have then left it to be 1990 if this would have kept to be true, and they would have then had $21,615,725.72. So in 1990, they would have had over $21 million. Then if they would have done this again, spend 3/4 of it, which would have been roughly a little over $15 million, reinvest $5 million. You can see how this would really have grown just rapidly. Now you might be thinking, well, where are they going to find a bank that has 5% interest? And right there you have a point, because interest rates right now for savings are just real low. But the concept is good and kind of fun to think about.